how to multiply two functions under differentiation. Now this topic today will give you a clear insight of how it works. Here's it. Product rule. Now product rule is the process whereby two functions are multiplied together. Now if you look at it so closely, you observe that when you have two functions, remember, under product rule, you have different kind of functions. I'm going to give us 7 basic standard derivatives which we are familiar with. Now you have y dy dx. Now note that this dy dx is the first derivative. Now when you say y, when under y, when you say sin x, when you differentiate sin x, sin x is what? Cos x. Now also when you differentiate cos x, cos x is what? Minus sin x. When you differentiate tan x, tan x is what? Sec square x. Now when you differentiate exponential function, it still gives you an exponential function. When you differentiate a polynomial function, this gives coefficient of n minus 1. When you differentiate inverse function, at this time we are going to be seeing the inverse function as lim x. So you have this. Now note, when you differentiate a constant can just be 20, 10, let's say 10. That gives you what? 0. So note that these 3 are trigonometric function. These are trig function. Now note that this is an exponential function. Also note that this is a polynomial function. Note that this is an inverse function. And finally, this is a constant. Please note, these are standard basic derivatives. These are standard basic what? Derivatives. Now let's take some examples. When you have y equals sin x cos x, y equals sin x cos x, and don't forget that the statement is find the first derivative, which is dy dx. Now this is a product of two functions. What kind of functions are these? These are trigonometric functions. I gave previous examples on that. Now if you look at this so closely, you see that from those derivatives I gave previously, I said sin x is cos x is minus sin x. Now if you come to this place, the formula for product rule is just simply dy dx. You have dy dx equals u dv dx, u dv dx plus v du dx, plus v du dx. But note that it can be reversed. What do I mean by that? It means that it can also be v du dx plus u dv dx. Still the same, because addition brings them together. If you say 2 plus 3 is the same as 3 plus 2, which still gives 5 on both cases. Now, the first thing is to identify these functions. Now, the basics of product rule originates from y equals sine x. Comes from y equals uv. So this was differentiated, which led to this formula you have here. Can you see? So if you substitute this now, this will be a u and this will be a v. So from now your u is sine x. So that means you can just put u directly here. dy dx, dy dx equals sine x. If you have sine x. Now, your v is cos x, but because it is a dv dx here, so it means that you are going to differentiate cos x. And that gives you what? When you differentiate cos x, that's minus sine x. Plus, your v is a cos x. Put cos x here. Then your u is sine x. But the formula here states that it is du dx. So since you have that, that makes, when you differentiate sine x, that gives you cos x. So cos x comes here. So finally, you multiply both cases. When you multiply this, sine x times minus sine x gives you what? Minus sine square x. There's nothing like sine x square, x raised to power 2, no. It's sine square x. But in this case, it is a minus sine square x. Plus, cos x times cos x gives you what? Cos square x. You can leave your answer like this, but it's good for you to rearrange it. So that is cos square x minus sine square x. So this is your final answer. This is what? Your final answer. So this is it. So if you have this, then we can take a very good look at another example. Looking at another example, you see so clearly that, let's say I want to deal with exponential function and a polynomial function. If I have y equals 3x squared, then e raised to power x. So the statement here is find dy dx. Find dy dx. Like I did previously in the first example, what you do is represent this with a u and represent this with a v. And don't forget that this came from y equals to uv. So what I'll do here is I'll write my formula out, dy dx. If I make this a dy dx equals, then u dv dx then plus v du dx. So right here, it means that my u is a 3x squared. I'm going to put u directly down here because that's exactly what it represents. So that's my u. But what is my v? My v is ax. So dv dx remains as ex. Don't forget that previously we said that when you differentiate an exponential function, it gives you the same. So it remains as that. So ex for v becomes ex. So we are going to put ex here. I like using brackets in this case. Plus, what's your v? Your v doesn't have any dx underneath, so that makes it ex. It still remains as ex. Then look closely. Your u is 3x squared. But since it is du dx, you are going to differentiate this. Then if you have, of course, when you differentiate 3x squared, if it is a y initially, so when you do your dy dx here, dy dx is more or less like you are putting a 2 down. You take this 2 down to come and meet this. It becomes a 2 here. Then you minus 1 from whatever you have taken down. So when 2 comes down to meet that, that's 6x. That's 6x. So this is 6x plus, okay, 6x, 2 minus 1 is 1. So that means that what you have here will be what? 6x. Of course, 6x raised to 1 is the same thing as 6x. So look closely. You have to extract what seems to be common in this answer. So ex is common, 3 is common, and x is common. That makes it very simple. So that means you have 3, x is common, then ex is also common. So when you extract all of these out, leaving the rest in bracket, you will be left with x plus 2. Yes, you will be left with x plus 2 because when 2, so you have plus 2 because when you divide 6x by this, you have 2. So this is a 2. So at the end of the day, when you multiply this and this, you have a 6x e raised to power x, which is an exponential function. So thank you very much, guys. So see you in my next video. Bye.